Hello, welcome to ANS Solver. This is the third question of the paper. So, Sumitra has a six-sided die. She suspects that it is biased so that it shows a 6 less often, okay, than it would if it were fair. Now she decides to test the die by throwing it 30 times and noting the number of throws on which it shows a 6. Now in part 1, it shows a 6 on exactly 2 throws. So I need to use a binomial distribution to carry out the test at 5% significance level. Okay, so what do I need to do? First state the null hypothesis. Correct? The null hypothesis states that the probability is equal to 1 over 6. Correct? Because first we assume that the die is fair. Correct? The alternative hypothesis is the rival claim, which says basically the probability is less than 1 over 6. Basically, the rival claim. Correct? Now I basically write the probability with x. I know my test value here is 2. And what will be the sign in the middle? If this here is less than, I'll have a less than here, but an equal to because of the test value. Correct? Sorry. Yeah. So now I know to calculate this, I need the probability of x equals to 0 plus the probability of x equals to 1. Correct? Plus the probability of x equals to 2. Agreed? Now the formula which I use is simply NCR multiplied by P, correct, raised to R multiplied by P raised to, sorry, not P, Q. Q is basically 1 minus P raised to N minus R. Correct? So using this formula, I can simply write this as, I know I threw this 30 times. Correct? So I write 30 C0 multiplied by 1 over 6 raised to 0 multiplied by 1 minus 1 over 6 is 5 over 6. Correct? Raised to 30 plus 30 C1 multiplied by 1 over 6 raised to 1 multiplied by 5 over 6 raised to 29. Correct? Plus I can simply do 30 C2, correct, multiplied by, I can do 1 over 6 raised to 2 multiplied by 5 over 6 raised to 30 minus 2, which is 28. Agreed? So now, as you can see, this is very tedious to write everything on the calc. So I can do a simpler thing on the calc. Okay, so on the calc, okay, you can simply click on shift. When you click on shift, okay, you can click on log. Correct, the log button, which looks something like this. So you'll get a big summation sign with a box here, and a bracket. Correct? Here you're calculating the summation from 0 to 2 inclusive. So what you simply do is write 0 here, write 2 here. And in the bracket, you simply write NCR, which is basically 30CX, right? X. X will basically take all the values from 0 to 2 inclusive, multiplied by 1 over 6 raised to X, multiplied by 5 over 6, correct, raised to 30 minus X. Correct? This is what I'll write. I'll just remove this. Correct? This is what I'll write. Now to write an X, I need to click on alpha and the closing bracket button. Correct? That's what I click on simply. So now when I click on this, I get my answer basically as 0.103. Now this is the probability. Now I compare the 0.103 with the significance level. My significance level I know is simply 5% here. So 5% I know is basically 0.05. I know 0.103 is more than 0.05. That means I simply write do not reject, correct? Do not reject the null hypothesis, correct? And I can simply say there's no evidence at 5% significance level, correct, that the dye, correct, the dye is biased, correct. This is what I can simply state. Now I'll go to part 2. Later, Sumitra repeats the test at 5% significance level by throwing the die 30 times again. Find the probability of a type 1 error in the second test. So you need to know a type 1 error basically means the probability when you reject your null hypothesis, but a null hypothesis is true, correct? In simple words, you basically need the probability of the critical region, correct? The critical region is basically the region from where the rejection starts, because you need to reject your null hypothesis. So now let's find the critical region first. Okay, I know I can make this calculation much simpler because I know the probability of x less than equal to 2 was not rejected, correct? So I can simply say the probability of x less than equal to 2, okay, was not rejected, correct. This is what I can write. So now I know even 3, 4, 5, 6, 7, like that is not rejected. So I take a value less. Let's say I take the probability of x less than equal to 1, because I know the probability here will be lesser, correct. So I again use this formula here, correct. And if you followed part 1, what I can simply do is I can simply write this down, okay. I can follow these steps, but here instead I'll just write it here instead of 2, correct. I remove this and type 1, correct. This is what I can simply do. So now when I do that, I'll just write the steps because writing the steps is important. So I write 30C0 multiplied by 1 over 6 raised to 0 multiplied by 5 over 6 raised to 30 minus 0, which is 30, correct, plus now for 1 also. So I'll do 30C1 multiplied by 1 over 6 raised to 1 multiplied by 5 over 6 raised to 30 minus 1, which is 29, correct. Now when I solve this on the calci, I get my answer basically as 0.0295. Now I compare my 0.0295 with my significance level, which is 0.05. As you can see, my 0.05 is more, correct. That means I'm rejecting this, correct. So I can simply say x less than equal to 1, okay, is basically my critical region. Now I need the probability of the critical region, which we already calculated. Basically I need the probability of x less than equal to 1, which is simply 0.0295, correct. This is what I can write as my final answer.